For trackless wastes, the trackless train. This is no ordinary train. Each unit is self-propelled by powerful electric motors in the wheels to transport huge payloads with equal ease across desert sands or Arctic wastes. Aluminium's light-footedness and weather defiance play important roles in LeTourneau's mammoth new trackless train. This print ad, which featured in a series of magazines in the mid-1950s for the Canadian company Aluminium Limited, shows a high-tech vision of the future. As the world entered a new era and age of aluminium use, so came the vision of a vast all-terrain trackless train made with and extolling all the virtues of this lightweight futuristic metal. However, while the use of aluminium would only grow and develop as time went on, LeTourneau's trackless train would prove to be an altogether less successful innovation than this advert would have led readers to believe. However, for a few years in the mid to late 50s and early 60s, a series of innovative and highly unique vehicles were tested in both the punishing Arctic North as well as the boiling deserts of Yuma, Arizona. These were the incredible trackless trains of R.G. LeTourneau Limited. Like many of the company's inventions, each one would be a one-of-a-kind invention, and they were perfect examples of the eccentric and wildly creative style of their inventor. They were ahead of their time in numerous ways, but quickly found themselves outdated and outpaced by other forms of rapidly developing technologies of the day. While they may have never seen any widespread use or success, they remain some of the longest, largest, and most eccentric overland vehicles ever built. But who built these vehicles? Why were they made? And where are they now? Well, to understand the how and why behind these vehicles, we must first start by looking at the man and the brains behind both the land trains and the amazing technology that powered them, R.G. LeTourneau. Robert Gilmore LeTourneau was born on November 30th, 1888 in the small town of Richford, Vermont, along the Canadian-American border. The fourth of 7 children, Robert was, according to his mother from his earliest days, restless, inquisitive, energetic, determined, and ambitious. To his father and brothers, he was destructive, rebellious, stubborn, and fanatically determined to amount to nothing. LeTourneau was a relentless worker and inventor, with only his religious commitment to God placing higher than his dedication to work. Dropping out of school at age 14, he soon found himself travelling across the United States, where he picked up the skills of welding and fabrication, as well as a number of contracts and business enterprises that brought him into the world of heavy plant machinery and earth-moving equipment. LeTourneau was no stranger to setbacks and misfortunes in life either, but despite many struggles early on in both his life and business, his skills in design, problem solving, and the creation of various earth-moving machines soon led to the steady growth of his business, R.G. LeTourneau Incorporated. The combination of his company's factories and workshops, as well as R.G. LeTourneau's wildly creative and often eccentric inventions, led to a vast catalogue of wheeled and tracked machinery that could conquer and adapt to any and all situations. One of the biggest early successes was the early Turnapool, a high-speed, self-propelled tractor/scraper that outclassed traditional tracked machinery of the time due to its large rubber tyres that gave the vehicle far more speed and manoeuvrability than its tracked-based competitors. By the time World War II rolled around, LeTourneau's company and the various models of large earth-moving equipment they produced was in a prime position to take advantage of the Army's need for large plant equipment, but also a company that was willing to fabricate and adapt machinery based on the ever-changing needs of the military. LeTourneau's company would go on to provide almost 70% of the earth-moving equipment used in combat during World War II, and would mark an important direction of the LeTourneau company as it worked to fulfill the often experimental demands of the US Army. Following the war, R.G. LeTourneau Limited changed. The company's earth-moving equipment line was sold to the Westinghouse Company for $31 million, over $350 million in today's money. Now, out of the earth-moving business, R.G. LeTourneau sought to invest his money in other enterprises. The relentless inventor in him saw potential everywhere, from oil rigs and forestry, steel fabrication, and, of course, lucrative and cutting-edge military research and development proposals. More than that, however, he was keen to perfect what he considered to be one of his most revolutionary ideas, his diesel-electric drive system. It was the powertrain that would form the basis for many of LeTourneau's future designs, and the invention that would make the massive land trains feasible. On November 17th, 1950, he unveiled a prototype military aircraft tow tractor called the Turnitow, powered by this unique diesel-electric drive system. Such a drive had been around since the 1940s, but it wasn't until the sale to the Westinghouse company that LeTourneau had the capital to re-engineer the idea into what would eventually power the land trains and other LeTourneau creations. The principle of the diesel-electric drive system was simple. Much like a modern electric car, electric motors could be fitted to each wheel to provide independent power. Unlike an electric car, however, power was drawn from a diesel engine generator that was fitted on board. The four-wheel drive and steer Turnitow was certainly not the first vehicle to be powered by a diesel-electric drive. However, at the time it was only commonly found in locomotives as well as some large, highly specialised military and mining equipment. Interestingly, it had also been used on a similarly large wheeled vehicle from the 1930s, the famously ill-fated Antarctic snow cruiser. Built for the United States Service Expedition in 1939, this huge exploratory vehicle had been built as a self-contained mothership for traversing the vast stretches of unexplored land on the interior of the Antarctic ice shelf. Powered by a similarly innovative diesel-electric drivetrain, it also utilised huge balloon wheels and was very much reminiscent of the designs of R.G. LeTourneau's later land trains. The snow cruiser, however, was found to be underpowered and unreliable, and after a few failed attempts at operating in the frozen Antarctic landscape, it was abandoned, buried forever in drifts of Antarctic snow. The key difference between these previously used, less successful diesel-electric systems was that while most existing systems mounted the components and motors on or inside the axle housing, LeTourneau moved them to the actual wheel mountings themselves, eliminating the complicated extension of drive shafts and allowing much greater flexibility on the drivetrain layout. In his autobiography, LeTourneau describes his initial pre-war experiments with these electric motors in his classic layman style, and how at the time technology was not advanced enough to make the system work effectively. I had it all figured out. I built 4 big steel wheels, and into the hub of each wheel I installed a second-hand electric car motor, so geared that it would cause the wheel to turn around it. Those were pretty big wheels, and it would be hard to steer in mud, so I geared another electric car motor to the front wheels to give me electric steering. For the supply of electricity, I welded a big Navy surplus generator to the front of the machine and powered it with a locomotive auto engine recovered almost intact from a wreck. No clutches were needed, no transmission system, no brakes, just some flexible electric cable to carry the power to each motor. Nothing for the operator to do but push buttons, occasionally pouring a little more gas into the locomotive in hard going. And it worked! But my electric wheel had a hard row to hoe before it got into the ground commercially. Both at the start lacked, among other things, the contributions from the other fields of science needed for their development. By the 1950s, however, science and motor technology had caught up with LeTourneau's forward-thinking ideas, and these independently powered wheels meant that machinery and designs could be fabricated in a more modular fashion. Their work in supplying the military during World War II had taught the LeTourneau company how to design machines to very tight timeframes and to meet incredibly specialised purposes. The company began producing countless inventive designs of all sorts of military and civilian uses, almost all of which utilised these simple, powerful, bolt-on electric drive wheels with power delivered via onboard diesel generators. From gigantic tree crushers such as the Series G150 to more inventive military solutions such as the Series MA31 landing craft retriever, which utilised huge 120-inch diameter electric drive wheels to wade deep into water to retrieve capsized landing craft. Many of these inventions were highly experimental, and in the 1950s the LeTourneau company began development on what would become one of their most experimental and most distinctive and unusual vehicles, the first trackless train. In 1953, the R.G. LeTourneau company began development on their first trackless train. Since the sale of their earth-moving business to the Westinghouse company, they were prohibited through a non-competition clause to build or sell any earth-moving equipment. Logging equipment, however, was permitted, and so was born the VC-12 Turner train. The VC-12 was actually the second Turner train, the first having been an experimental version built and tested in 1953, with the VC-12 coming along in 1954. The setup and design for both was relatively simple and reminiscent of LeTourneau's earlier experiments with electric drives before the war. For the VC-12, the front lead tractor or locomotive pulled behind it 3 20-ton trailers, each one fitted with 4 LeTourneau individual electric traction wheels. A single 500 gross horsepower Cummins VT12 diesel engine mounted on the lead tractor provided the power to each of these trailers. Eventually, this was upgraded to a total of 7 trailers, and a second Cummins VT12 was added, bringing a total of 1,000 gross horsepower and allowing the huge original 32-wheeled Turner train to be capable of towing up to 140 tons of material. The company showed off the new Turner train on undeveloped logging trails around their headquarters in Longview, Texas, as well as taking it on the highway and even showing off its impressive turning capabilities by driving it through town. The Turner train was eventually demonstrated to the US Army Transportation Research and Development Command, or TRADCOM. No orders ever came from this first generation Turner train, but the Army were interested in the potential for large haulage vehicles, and especially vehicles that could be capable of operating in extreme Arctic conditions for an important task that the United States and Canada were about to embark upon. A joint US-Canadian project was underway, which would see the building of one of the largest and most ambitious construction projects in history. And to complete it, they would require machinery capable of moving hundreds of thousands of tons of material and equipment to some of the harshest, most challenging environments on Earth. The project was the Distant Early Warning Line, or the DEW line, and it would require the help of LeTourneau's land trains. Immediately following the conclusion of the Second World War, both the United States and Canada began plans to collaborate radar and early warning installations that could better protect home soil from potential invasions, especially from the threat of potentially nuclear-armed Soviet bombers that could exploit the Arctic as the closest flying route to attack and launch a preemptive strike on the United States and Canada. From as early as 1946, plans were put in place for the first line of radar stations known as the Pine Tree Line that ran along the 50th parallel, jointly manned by United States and Canadian Air Force personnel. This line was followed by the more northern Mid-Canada Line, but by the time both the Mid-Canada and Pine Tree lines became active, advances in Soviet technology and drawbacks relating to the design of these radar lines left them relatively obsolete, and by 1954 plans were already in place to supersede them with a more extensive, more highly advanced radar station line in the very furthest reaches of Arctic territory and as close to Russia as possible. Stretching from the furthest northwest coastlines of Alaska all the way to the eastern shores of Greenland, this vast 63-strong line of stations would be located on the 69th parallel, 200 to 300 kilometers north of the Arctic Circle. Some of the stations would be unmanned, some manned by small 3 to 4 person crews, and some stations would have sizable bases with everything from workshops and libraries to accommodation for dozens upon dozens of personnel. Each station would have to be robust, self-sufficient, and filled with heavily redundant systems for round-the-clock operation in some of the harshest environments on Earth. To facilitate the build of this early warning system in the far Arctic North, an area that few humans had ever even visited, it would require huge levels of infrastructure and uplift of both men and materials. In total, some 25,000 men would be required, and over 460,000 tons of material would be needing transport to multiple remote outposts in some of the most difficult to reach areas found anywhere on the planet. Vast airlifting operations would be utilised, as well as ship-based transportation and landings. But for some of the most inland, remote stations locked in by snow and ice, men and materials would have to traverse overland, pulling with them the equipment and supplies they'd need to build and man the sites. While it may have primarily been a military endeavour, the main contractor for the building of these stations would be the Western Electric Corporation, and through them, an Alaska-based hauling company called Alaska Freight Lines secured a contract to move freight to some of these distant sites on the Arctic Ocean. The company was owned and operated by one of Alaska's most experienced truckers, Alfred Gesey Jr., who had pioneered many of the early road networks in Alaska, and Al, as he was known, had an ambitious plan for what would be his biggest job to date. Gesey planned to move 500 tons of freight over 400 miles across the deep Alaskan and Canadian far north, and through places that few dog sleds had ever even travelled. The trip would involve 32 diesel trucks and trailers, hauling everything from fuels and building supplies to prefabricated huts and radar dishes to be deposited at designated locations along the DEW line. Several D8 Caterpillar ploughs would cut through the thick drifts of snow to create navigatable routes, and both spotter planes and local guides would scout out the route ahead. It was an ambitious plan, and the company wouldn't be paid a penny until the last load of freight was delivered. It was a highly risky bet, but to pull off this job, Ghezzi had a trick up his sleeve: the snow freighter. According to R.G. Letourneau, Al Ghezzi had told him he didn't want a platform to shoot grouse off of, he wanted a real train, and the Letourneau company planned to deliver just that. The contract called for a 6-unit off-road freighter capable of carrying up to 150 tons of cargo. It would need to be able to track through large drifts of snow, cross rivers up to 4 feet deep, and be able to function in temperatures as low as minus 68 degrees Fahrenheit. Signing the order on January 5th, 1955, the Letourneau company got to work almost immediately, and in an incredible feat of rapid design and engineering, by February 17th, the third Turner train ever built, dubbed the Snow Freighter, was almost complete. Each unit or car was 16 feet wide and 40 feet long, and each featured 4 huge 88-inch wheels with a diameter of 38 inches. The chassis of each car was designed to be both strong and simple, with a single central frame intersected by 2 oscillating axles that ensured all 4 wheels remained on the ground over rough terrain, and also contained the mountings for the motorised wheels. From this central frame, outrigger ribs then formed the supports for each bed of the car, on which anything could then be attached or fabricated. One such car became the lead tractor and was fitted with twin 400 horsepower Cummins diesels, along with inline AC/DC generators that could produce the necessary power for all 24 independent wheel motors. Contained in this engine room was also the 2,000-gallon fuel tank, intentionally located near the heat of the engines to prevent any freezing. Up front was an elevated insulated cockpit for control and navigation of the Snow Freighter itself, and behind it, accommodation and living quarters for up to 4 crew. After some early testing at their plant in Longview, Texas, the second generation aluminium-built Turner train, measuring over 274 feet in length, was completed. Built in only 6 weeks, it was an impressive feat of engineering and contained numerous innovative features such as oscillating axles, regenerative braking systems, and electric front axle steering. Before leaving Longview, it was painted in the Alaska Freight Line's livery of orange and black, disassembled, and then packed onto a railroad train to be shipped first to the Alaska Freight Line staging area in Seattle, Washington, and then to Circle City, Alaska, where it was to be assembled for the journey north. With their secret weapon in tow, the giant train of trucks, caterpillars, and their cargo set out in the fall of 1954 on what would be one of the most epic overland crossings in the history of the Arctic. It was a multi-stage operation, with first the local guides and dog sleds scouting out the route alongside a company plane, which dropped coloured stakes into the snow to mark out a safe passage. Caterpillar bulldozers then ploughed through the thick drifts of snow, first along the established routes such as the Steese Highway, and then onto the uncharted territories, creating 25-foot wide paths through drifts of snow and landscapes few had ever journeyed on before. Behind them, the huge convoy of Mack trucks and the Snow Freighter itself slowly followed, towing the hundreds of tons of materials required for the stations located on the Arctic Sea. Engines were kept running 24 hours a day, with sometimes only a few miles of progress being made through the unforgiving conditions. Drivers, who were usually paid $3.75 an hour, were usually behind the wheel for up to 15 hours a day or more, having to fuel up, fix any mechanical issues, and then crawl into bed for 3 or 4 hours of sleep before getting back up and back onto the road again. The convoy carried with them a bunkhouse, which slept 16, and also contained a shower, toilet, tool shed, and workshop, but there was little comfort for the overworked drivers and mechanics. The incredible fortitude and strength of these crews was only matched by the unbelievable feats that their trucks were forced to perform in some of the toughest conditions imaginable. Breakdowns were a regular occurrence, a common problem being snapped axles that would often break due to a combination of the heavy loads and extreme cold making the metal itself brittle. The convoy would get stuck in snowdrifts, and trucks frequently risked jackknifing or skidding off steep cliffs or uneven tracks. Slowly but surely, however, they made their way northeast, following the Yukon River as they forged deep first into the Alaskan, then Canadian wilderness. The convoy refueled at the refinery of Norman Wells, Canada, before traversing over 150 miles of the frozen Great Bear Lake and finally making it to their last destinations on the Arctic Ocean, where the materials were required for the dew stations. The trip, however, was only halfway done. Now unloaded, the convoy, including the new Snow Freighter, faced the long journey back the hundreds of miles they had come. To quote Cliff Bishop in his book 18 Wheels, A History of Trucking in Alaska, These convoys had travelled east on such trips far enough to have almost been due north of Michigan, a long ways east from Fairbanks and Eagle, Alaska. The drivers were truly pioneers of the Arctic far north, and I feel it's a great privilege to have known or worked with most of them. The Snow Freighter had also performed admirably and had created quite a stir in the press. Documentary films frequently showed off the Snow Freighter, now nicknamed the Monster. The freighter was the biggest success of the LeTourneau's turn of trains so far, and was frequently mentioned in the company's newsletters from the time, as well as in promoting its futuristic aluminium construction. Even the Soviets were aware of the Snow Freighter. They had been carefully monitoring the progress of the construction and had even been tracking the progress of the convoy via high-altitude bombers and relaying their progress via radio, offering a stark reminder to the crews of the true nature of their mission. The convoy eventually made it back to Fairbanks, Alaska, where plans for a second convoy were already in the works. This, however, would prove to be the undoing of the giant Snow Freighter. On this second trip of fall 1956, the Snow Freighter made it as far as Eagle, Alaska, when disaster struck. About 30 miles east of Eagle, the Snow Freighter was being driven by the crew's cook, who was more inexperienced with the controls. Upon reaching a steep hill, he lost control of the freighter, and it ended up jackknifing, pinching together the fuel and electrical lines, and causing a fire. Unable to tackle the blaze, the control car burned beyond repair and left the huge machine stranded and inoperable. Luckily, none of the crew were injured, and while breakdowns and mechanical issues on the convoys were common, such a catastrophic failure meant that for the vast Snow Freighter, there was nothing more that could be done. The 5 trailers were offloaded onto trucks and Caterpillar trains, and the monster was left behind in the snow. Now stranded and powerless, trucker Cliff Bishop helped drive for a contract to retrieve the burnt-out cab and trailers. The huge size of the Snow Freighter, which towered above the Mack trucks that were tasked with hauling it home over rough tracks, fast-moving rivers and snowdrifts, was an incredible challenge, especially due to the now useless geared motorised wheels, which were difficult to move freely without power. Finally, though, 6 Mack trucks managed to drag the once mighty snow cruiser and trailers down the Taylor Highway and into Tok, Alaska. The freighter and her trailers were eventually moved to a site next to the Steese Highway in Fox, Alaska, where it still remains, burnt out and abandoned to this day. The now long-defunct Alaskan Freightlines is still painted on the front of her cab, and her unique motorised wheels are still visible, rusted and derelict, over half a century later. While Cliff Bishop left the freighter with a great respect for both her engineering and the crews who operated her, the Snow Freighter was let down by the same issues that plagued many of LeTourneau's products. Most were unique, experimental, and built to order, and left many operators of their equipment in difficulty when repairs or servicing were required. While her ability to tow and operate in harsh environments was second to none, the sheer number of parts and ease of repair that the more regular Mack trucks and Caterpillars offered as convoy vehicles made them far more usable and suitable for long-distance overland expeditions. Algesi would not go on to fix or order another Snow Freighter, and his company, Alaska Freightlines, would end up heavily laden with huge amounts of debt, partly owing to the construction, operation and failure of the Snow Freighter. Despite her somewhat disastrous end, however, for a first-of-her-kind vehicle, the Snow Freighter had proved itself as highly capable in the environments that she had been designed for, and LeTourneau was still working with another potential major customer on the development of large overland travel, the US military. In 1954, LeTourneau had produced the Series TC-264, also known as the Snow Buggy, under military contract. This concept vehicle originated from a request from the US Army Transportation Corps for vehicles to assist in and traverse environments such as the Greenland ice cap. Powered by an Allison V1710 engine that ran on aviation fuel, all 4 wheels of the Snow Buggy were driven by AC electric traction motors and utilised huge Firestone 48 by 68 tyres that were 10 feet in diameter and 4 feet wide. In an interesting connection to the earliest pioneer of Antarctic overland travel, Dr. Thomas Poulter, the designer of the original failed Antarctic snow cruiser, actually visited the LeTourneau factory in Longview to inspect both the original VC-12 Turner train and the Snow Buggy. Only one single snow buggy was produced, and while it did see some limited testing in the Arctic, no further models were ever produced. The military were, it seems however, impressed by the performance of both the snow buggy and Gezzy's snow freighter, and both designs would come together when the military commissioned LeTourneau to produce a concept land train for their own testing. As a result, on the 1st of January 1955, the US Army hosted an acceptance ceremony for the LeTourneau's newest creation at their Longview plant in Texas, the Logistical Cargo Carrier. To the military, this massive land train was dubbed the LCC-1, or the Logistical Cargo Carrier. To the company, it was labelled the Model YS-1 Army Snow Train. Similar to the previous snow freighter, it was made up of a leading power unit and 3 trailers, giving it a length of over 173 feet and driven by 16 electric traction wheel motors. The combined load capacity for the 3 trailers was 45 tons, and a single Cummins VT12 engine rated at 600 gross horsepower provided the necessary power for this overland snow train. The snow train also utilised the same Firestone 48x68 tyres from the earlier snow buggy, with the front cab and trailers sitting alongside the huge wheels rather than above them on the snow freighter, reminiscent of the earlier VC12 Turner train. As a result, the snow train had a slightly squatter and more rugged appearance, perhaps suiting the environments that it was designed to operate in. The front cab contained the driver's controls, which were surprisingly simple for such a huge machine, and also a bubble dome, which would be used to take readings from the stars for navigation. These were commonly used in aircraft at the time, would also be featured in the Soviet Kharkov-Chankas, the massive tracked overland expedition vehicles that were being built for the Soviet Antarctic Service around the same time. The control unit was articulated, with the command cab and crew space up front and a plant room to the rear, as well as a small crew space. The rear of the lead car also featured a crane located in the front of the fuel tank. This could be used to assist in the removal or changing of these 16 massive wheels, each one of which weighed an incredible 2,322 pounds. In both design and function, the crane resembled that found on the 1939 Antarctic snow cruiser, which was similarly intended to be used for the unloading and loading of wheels. The wheel rims also featured small hooks that could be used to attach traction aids or snow chains for better traversal. The LCC-1 went through numerous trials and testing over the years as the Army determined its capabilities and functions. Initially, the lead control unit was relatively clean and featureless, with just 4 lights up front along with the printed words US Army. Eventually, a series of spotlights would be added, as well as a front frame that was designed to support an experimental radar setup, as well as the logos and markings of the US Transportation Corps. Another addition would be a large snow deflector mounted under the front bumper and intended to help clear built-up snow ahead of the train. By the 1960s, it seems the testing and use of the LCC-1 had started to wind down. In April 1964, it was sold as surplus and was reported to be located in Fort Wainwright, Alaska, facing an uncertain future. It would in fact sit unused and relatively forgotten for almost 50 years, until in 2011 it was placed on indefinite loan to the Yukon Transportation Museum and transported to their premises for display. The lead car of the original snow train and some of the trailers are now proudly on display at the museum, one of the largest and strangest overland vehicles ever made, and now thankfully preserved for all to see. The testing of the LCC-1 had proved to be successful enough for the Army to once again commission LeTourneau for another addition to the land train project, and in 1958 the United States Army requested a quote from the company to research and develop a large overland train, the final expression of what both Tradcom and LeTourneau had envisioned as the ultimate overland transportation vehicle. This final design would be intended not just for the snowy Arctic conditions, but also for hot, sandy deserts and arid sands, much like the vision promoted in the aluminium company's advertisements. Initial designs and drawings started as early as 1955, and this final iteration would come to even dwarf the previous snow freighter and LCC-1. Final design approval came in 1960, with fabrication taking place through most of 1961. By 1962 it was complete, and testing finally began on the simply gigantic model TC497 Overland Train Mark II. To this date, one of the longest and largest vehicles ever built. The sheer size of the Mark II was almost hard to comprehend. Made up of 13 individual cars, the Mark II stretched out a staggering 572 feet with an unladen weight of 300 tons and a gross weight of 450 tons fully laden. 54 electric drive wheels supplied power and traction to each of the cars, with the gigantic lead car utilising 3 sets of the massive 10-foot tall tyres. The design and powertrain of the Mark II was an evolution of the previous overland trains. One notable departure was that instead of generating power from the lead car, the Mark II used 2 power trailers at the rear to provide electricity to the independent wheel motors. While the lead car still had its own power, this would only be used for manoeuvring when all the trailers had been disconnected. Furthermore, while previous models of the overland trains had utilised diesel-electric powertrains, the Mark II would use 4 10MC gas turbine engines rated at 1,170 gross horsepower each, with one engine located in the control car and only to be used when disconnected from the train, and the remaining 3 located in the rear power trailers. This gave the massive train a total power output of 3,510 gross horsepower when fully connected, and the capability to tow around 150 tons of cargo. The top speed of the Mark II was an impressive 20 miles per hour and a cruising range of around 350 to 400 miles, which could be increased by the addition of an auxiliary fuel cell, bringing the total fuel supply to around 7,833 gallons. The design of the Mark II command car differed heavily from the previous snow train, with a larger, more elevated cab that stood over 30 feet tall to give a full 360-degree view. Inside, the controls, however, were reminiscent of those found in previous models, now with the addition of more radar controls, as well as a gyro compass and other navigational equipment. The radar was now also more integrated into the design of the car, mounted on the roof and reminiscent somewhat of a ship's bridge. For steering, the Mark II also no longer required articulation due to a clever all-wheel steering system that programmed the wheels of the cars behind the control car to turn at the same point the control car had originally passed over. Perhaps one of the most impressive aspects of the command car, however, was the crew accommodation. In front of the engine room contained lockers and sleeping accommodation for a 6-man crew. A toilet was also built into the design, as well as a galley and living space that featured a full-size oven, sink, storage areas, as well as even a combination fridge-freezer. Small design touches were also added to accommodate living in a moving vehicle, such as stash-away seating and special edge trim for the tables to stop items falling during transit. The Mark II was truly the pinnacle of land train design. It was a vast, heavily powered machine capable of traversing huge distances. As early as the mid-1950s, the US military was even looking at the feasibility of using nuclear power for overland trains, using compact power plants. In his autobiography written in 1960, R.G. Letourneau himself references this development. To develop the power needed for this train, I had to break with tradition again, this time disregarding the long popular diesel in favour of gas turbine engines, much like those used in turbojet aircraft. But the use of gas turbines is only a small part of it. They are but a stopgap to power the train through its primary testing state. After that, it will be powered by atomic energy, probably the first land vehicle to be so equipped. However, this wouldn't ever come to pass, and the Mark II would be the grand high watermark for the overland train. There were several factors that limited and eventually ended the development of the overland train for the US military. Programs such as the Army's nuclear power program, as well as expensive conceptual vehicles such as the overland trains that would hold them, were heavily scaled back in the 1960s due to budget constraints. With the ever-escalating Vietnam War taking up more and more resources, projects such as the Mark II overland train were seen as an unnecessary experimental expense. Furthermore, a technology was beginning to come online that would soon replace the usefulness and supersede the functions of the overland train, that being heavy-lift helicopters. The development of heavy-lift helicopters such as the Sikorsky S-58 or the massive S-64 Skytrain had come on leaps and bounds even by the early 1960s, and their speed, manoeuvrability and adaptability invalidated the majority of advantages that could be offered by the ultra-large land-based vehicle. In the end, the Model TC497 Mark II overland train, the final evolution of the incredible overland trains, never really came to prove itself outside of a few tests in the Yuma proving grounds. It was soon mothballed and mostly scrapped, save for the huge command cab, which still sits on a plinth outside the proving grounds to this day. Inside, the main power plant is now gone, but the fully equipped living spaces, toilet, and even command cab still sit almost as they were some 50 years ago. In the end, the world moved on from the strange and bizarre land trains. Probably some of their most recognisable legacy comes from the famous Bigfoot monster truck series, however. It has long been rumoured that the wheels for the famous giant monster truck Bigfoot came from wheels from the LCC-1 snow train. While the rims that Bigfoot uses, however, are definitely from an overland train and were reportedly found originally in a Seattle scrapyard, the rims differ to those used on the LCC-1 and are more likely to be from the TC-497 Mark II overland train. The Letourneau Company continued their development of the unique diesel-electric powertrains and eventually moved back into the earth-moving business, creating and developing huge, often strange one-off pieces of machinery such as the gigantic Series 6B electric digger or the TC-100 side dump hauler. However, in March 1969, Robert Gilmore Letourneau suffered a severe stroke from which he never recovered. He died on June 1st, 1969, at the age of 80. He was a man whose personality and inventive genius was only dwarfed by the huge machines he helped create, and Letourneau is considered to this day to be one of, if not the world's greatest inventor of earth-moving and materials handling equipment. His foresight and predictions into the future of power and electric motors were ahead of their time, and as Letourneau admitted himself, only limited by the constraints of the technology of his day. Not long after his death, the effects of stiff competition in the marketplace, as well as the company's somewhat experimental and often unpredictable products, began to take their toll on R.G. Letourneau Limited. In 1970, the company was sold for the first time to the Houston-based Marathon Manufacturing Company and became known increasingly for their manufacture of the Titan range of haulers for use in mines and quarries around the world. The Letourneau Company is still around to this day, however, and in the year 2000 they built the L2350 electric diesel front-end loader, which remains to this day the largest loader of its type. Letourneau machinery can still be found around the world, from cranes and log loaders to even oil rigs, but without a doubt, one of the most unique legacies left by the Letourneau name is their strange, huge and incredible overland trains and the amazing man who helped create them. Well, thank you very much for watching my video on the Letourneau overland trains. Snow Freighter, VC12, Snow Train, Overland Train Mark II. I've literally just finished the edit. You're seeing this live. I've literally just finished this and I'm now recording the outro. I was going to record an outro outside because I'm currently actually building a house in the woods in the middle of nowhere, but it's pitch black all the time because it's very, very north of Scotland. So I haven't really had much time to do that. But the reason I thought it was appropriate is because there's currently loads of gigantic earth-moving equipment all over my land. There's dumpers and diggers and rock breakers and everything. And it felt very appropriate that as I was editing this, you can literally hear the rock breakers and various things running in the background. You can probably hear it in the background of some of the stuff that I'm actually talking about as well too. So it's a good time to have finished it. Also, really glad to hopefully finish this and have it out by the end of the year, because this sort of completes a trilogy for me. In 2019, I released the video on the Antarctic Snow Cruiser. I then released a video in 2020 on the Kharkovchanka. And now I've finished this video on the overland trains. And I know that two of those, the first two are in Antarctica and this one's in the Arctic. But I feel, from the time period, from the technology that they were being used, the sort of retro-futuristic style, the fact of just how kind of unbelievable they are and what they were intended for, the three really go together quite nicely. And all of the videos all reference them. People always mention the overland trains in the Snow Cruiser video. People always mention the Kharkovchanka in the Snow Cruiser video, or vice versa. So I think that the three all go together quite nicely. And people have been asking for this for a long time. And I've been researching this off and on for about 2 years now. The script has been being worked on. I was trying to track down information. A lot of my researching usually happens by ordering lots and lots of books as much as I can. First thing I ever ordered was this. The thing that you saw at the very start of the video, for Trackless Wastes, the Trackless Train. An actual advert that would have been around the time of the Snow Freighter, because you can clearly see this is a kind of artistic rendition of the Snow Freighter. So yeah, that is kind of where it all began. I then managed to track down, with great difficulty, this 2009 issue of Classic Military Vehicles. Thank goodness to the random eBay seller who was selling this, because on the inside was a fantastic article with photos of the Snow Cruiser and stuff that I had never seen before, and to this day I've never seen online. There was some information in here though that I was a bit dubious about. I then managed to track down actually a couple of copies of R.G. Letourneau's autobiography. Fascinating man, well worth reading this book. It came out in the 1960s, obviously. This is, you know, because it's older, there's actually less references to the vehicles because they were kind of being manufactured at the time he was writing this. But a lot of insight, and just an absolute madman. He's fantastic. I mean, so inventive and so just passionate. He's somebody, I think, you know, there's a quote maybe in this book or somewhere else that he could build and weld a machine far quicker than he could draw a picture of it, you know, and I think that sums it up. Like, he was just so dedicated to the creation of stuff and dreaming up these sorts of ideas, and yeah, really, really amazing. So that gave me a little bit of a picture. Probably the best thing I found though, and there are links in the description to, you know, these books as well, but this is probably the one that I would recommend the most, Letourneau's Earth Movers by Eric G. Orlman. Amazing book. If anything, reading this book puts the overland trains in context, because when you look through this book, you will see so many unbelievable machines that you will scarcely believe that any of them are actually real. And what's more is a lot of them make the overland trains look normal. It is incredible. Incredibly high quality photos. I think just an amazing, it's like a coffee table book. The photography in this is amazing. And I will say, the Letourneau company had great photographers. I'm a photographer, it's what I do. And you can tell they knew how to photograph their products. And if anything, a lot of their products, it reminds me of the mad inventor from the Portal series, Aperture Science. It's just like, it's throwing out mad ideas all over the place, constantly. Like, you know, we'll make this side dump train, and then we'll, you guys in the military want a gun? Well, we'll put a gun on one of our big tractors, and then we'll give you that. And you know, I think one of the other things that Letourneau did was a big boat that could walk out of the sea. It had these big legs on it. There was a bizarre machine that I've seen footage of, I think, that could set down and build like a concrete house, basically. So the idea would be you could roll into town and build these big suburbs. And mad. Absolutely mad and fantastic. And of course, that's what's great. And there's a lot of stuff I was not able to cover in this video. There are actually overland trains that I didn't mention. There's one in particular that is the side dump train. I think that's really it though, which was another kind of experimental train that was made, I think, between the Snow Freighter and the maybe the Mark II freighter. There wasn't that much information on it. I didn't really think it was relevant. I cut it for time. I didn't even mention though, Amtrak Wars. I don't know if any of you guys ever read these books. Amtrak Wars was a novel series in the 80s, and there's overland trains in it. It's a kind of post-apocalyptic Fallout style universe. Well, not really, but it's a post-apocalyptic American post-apocalypse. You've got all these different factions. Some are slightly culturally insensitive today, but they drove around in overland trains. One of the factions based down in Texas, which is appropriate. I think it was Texas anyway, because of course the snow trains were built in Longview, Texas. But yeah, I don't know how many people maybe saw this and were like, whoa, that's cool. Didn't actually realize these are real. Like, they actually made these, not with guns. And these ones, I think, have planes that fly off the top, but really good fun. And again, another example of just the stuff I couldn't talk about. I mentioned Bigfoot. That's not a point of contention, but a lot of people talk about Bigfoot. Oh, you know, the wheels from the Antarctic snow cruiser came to Bigfoot. No, they're from this, and they're actually from certain trains. And that's the other thing is, there's a lot of misinformation out there about these trains. There's a lot of stuff that I see on blogs that are reposted from other blogs, and there's rumors, and there's stuff that just simply isn't true. And that's why this took me so long to research. And the person who is responsible for this being hopefully accurate is Mark Moore. There's a lot of people I got to thank for helping bring a lot of this stuff together. But Mark Moore credit to you, man. He is something else. He's currently writing a book about these overland trains, and you know, he's got a wonderful website, overlandtrains.com. I think I'll put a link below. He's currently writing a book which is due out early 2022. And I managed to track him down because I saw a lot of kind of old forum posts and references to people discussing it. And I saw, I think, his name pop up a few times. And I managed to find an old website that I think he had when he was posting about the overland trains. And I found a cached version of the site on an archive website. And I emailed him and I said, listen, this is a weird question, but are you I do this a lot. I message a lot of people and I go, this is a weird question, but are you the person who X knows about this cave, knows about this strange machine? And he was like, yeah, I'm actually working on this book. And amazing. He sent me photos. We discussed in length a lot of the particulars and timelines, sent me photos and diagrams. His website is a wealth of information on the subject. His book is set to be, I think, the definitive history on all of this. I think it's going to be incredible. He has been talking to people directly involved with it, especially the Snow Freighter, which is a whole story in and of itself. You could have made a single video just about that. He even talked to Cliff Bishop, and Cliff Bishop, of course, is the 18 Wheels in Alaska. I have his books around here somewhere as well too. Cliff Bishop's still alive, that trucker that towed the Snow Freighter out of there. And these are the kinds of voices, you know, that we're losing. We are losing people from this time period, and you know, it's great that Mark's a little bit. It reminds me a little bit of the mini track video that I made, where, you know, passionate people finding out about these subjects, tracking down the people who are in the know and talking to them. I'm not talking about myself. I'm talking about Mark, talking to the people firsthand. Mark actually fact-checked my document for me. I sent him my script, and apologies, Mark, because I am a terrible writer, my grammar, my spelling and everything, but he looked through it, he gave me the information on what I got right and what got wrong. He corrected a lot of the stuff in here, which I had sourced and had actually been incorrect. And yeah, amazing. There's a few other people as well, though. I'll put a link down in the description, but folks who let me use their photos. Also, I think it's Margie who did a tour of the Mark II, because you don't normally get to go in there. It's just on a big plinth on display. They were currently at the time restoring it. They were restoring the interior that I was showing the photos of, because it's in pretty good nick. I think they were just kind of cleaning it up and restoring it slightly. And they got this amazing access just by chance to have a look around this amazing thing. And I messaged them and I said, listen, could I use that footage? I'd love to be able to kind of show people the inside of it currently. And they were like, yes, you can. Which is always appreciated. And, you know, that's the most amazing thing. The Snow Freighter, the Overland Train, Mark II, and the Snow Train, they're all still out there. You can go and see them. You could go to the Yukon Museum of Transportation. You could go to, I think it's the Gold Daughters, it's like a little kind of outdoor museum. They're the folks who own the Snow Freighter. And you can go down to the Yuma testing grounds and you can see all of these things. And for experimental vehicles that never really had much of a lifespan outside of a few months and years of development, for them all to still be around, and for the fact that you can go up and see them and look at them and go inside them, and for the Overland Train Mark II, the fact that it's still in even good condition is just amazing. I absolutely love it. So yeah, a very long project, which I am very glad not to see the back of, but I'm very glad to bring this to a close, because this was threatening to run on and on forever. The script had been sitting for ages and I neglected it for a bunch and came back and forth on it. It's been really good, and I'm really glad that I was able to reach out to Mark. If you guys are interested, I'd go to his website and I would keep an eye out for his book. I will let you guys know when his book comes out. I'll probably do another video, maybe just to promote his book when it comes out, because I think that is going to be the real history of this. I think I've really just given everybody the cliff notes here. I think a lot of the more interesting stuff and hearing firsthand from people is going to be the thing that I think really tells the story of these overland trains. But anyway, it's been a long year. And it's been a long process to bring this thing to completion, but we're done. So glad for you guys for watching and supporting me as always. If you are interested in supporting me, obviously you can like and subscribe and stuff, but I do have a Patreon as well too. You can go over there and chuck in a buck. You know, I don't post on there all the time, just because I'm a very busy guy, but you'll usually get some behind the scenes and I'll let you guys know updates on what I'm working on and stuff like that too. But anyway, Thank you very much for watching. I'm going to go, hopefully, publish this. Bye-bye.